Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another video in calculus about continuity. I hope that your knowledge and technique in dealing with functions and its uh, discussion on whether or not if the function is continuous will be enhanced and developed so that you can use that technique in dealing with your engineering subjects. So a function f of x is said to be continuous at x equals c if all three of the following conditions are satisfied. First, that the function value when x is c is existing, f of c exists, the limit of f of x as x approaches c exists also, and the last is these two values must be the same. So c limit of f of x as x approaches c is equal to the function value when x is c. So these are the conditions that must be satisfied completely for the function to be continuous. And in general, a polynomial curve or polynomial function is continuous for all values of its domain set R. So it is continuous. There's no break for polynomial curves. So take note of that because polynomial curves have no denominator. Lastly, a rational algebraic function is continuous except for those values of x for which the denominator vanishes. So the rational algebraic function is continuous only except for these values of x for which the denominator is 0. So that's that idea. So if there is no denominator, then the function has no points of discontinuity. So here is the problem. Here are the problems. If you want to anticipate the solutions to these problems, then you can by pausing the video. All you need to do is remember these conditions. So for number one, since there is denominator and we can factor this into x minus 4, x plus 4, then this function is discontinuous at plus minus 4. So we have x squared plus 3 over x minus 4 times x plus 4. So that will make 0. The denominator will be 0 when x is 4 and when x is negative 4. Therefore, the points of discontinuity would be plus minus x is plus minus 4. For number 2, this is a perfect square trinomial. We can factor this as x minus 3 quantity square. So that would be f3x plus 2 over x minus 3 quantity square. So the denominator is 0 when x is 3. So the point of discontinuity is when x is 3. Number 3, since the denominator is always positive for real values of x for the domain of this function, then there is no point of discontinuity for number 3. So none. Number 4, we can factor x in the numerator, x in the denominator, but since the denominator is 0 when x is 0, then we have x plus 3 over 4x squared. Sorry, number 4. I'm looking at number 5. Number 4 first. x plus 3 over 4x squared minus x plus 2. There are no real roots that will make the denominator 0 by checking the discriminant. A is 4, discriminant of the quadratic equation. A is 4, B is negative 1, and C is 2. So B squared minus 4AC, the discriminant is negative 1 squared minus 4 times 4 times 2, and that is negative. Because the discriminant is negative, there will be no real roots, therefore there's no point of discontinuity. So none for the answer. Number 5, we can factor x in the numerator, then x in the denominator. So x squared minus 3x over x times quantity x squared plus 2x plus 5. Although we can cancel x because that's the case, we can only cancel x if x is not 0. But because the denominator is 0 when x is exactly 0, then this x equals 0 will make the denominator 0, so that makes it discontinuous at x equals 0. Then x squared plus 2x plus 5 is a quadratic function. There is no real root again because b is 2, so 2 squared is 4, minus 4 times 1 times 5, so minus 20, so negative 18. The discriminant is negative, therefore there's no real root for this remaining factor. So the only point of discontinuity is x is 0. Number 6, I factor the denominator but not shown here by synthetic division. Number 6 would be 3 times quantity x plus 2 square over x minus 1, x plus 2, x plus 3. In evaluating limits, we can cancel x plus 2, but it is a break at x equals negative 2. So for the remaining simplified form, but when the denominator is 0, when x is 1, negative 2, and x is negative 3. So those are the points of discontinuity. 1, negative 2, and negative 3. Number 7, I also do not show the factoring technique in the denominator. You just have it in the preceding videos. I showed there the factoring technique by synthetic division, or you may look at Engineers in Progress. There's a video there, in so many videos in that playlist where I presented factoring by synthetic division. But since this is calculus, you should have a background on factoring by synthetic division already. If not, it only means that I think you're still not a student in calculus, because the knowledge of the basic mathematics such as algebra should be brought along here, or else it's difficult to survive calculus unless your teacher or professor is so considerate that you will be allowed to pass without learning something. Then you will find it difficult to pass the board exam. You will not become an engineer if you rely on your very considerate professor. So you should learn mathematics, you should learn calculus, because after all, it is your future that counts. It's not that uh, you just allowed to pass. Later on, you will find it difficult to pass your board exam, and you will not become an engineer after all. So you should survive, you should test yourselves if you are really uh, mm, that good enough to survive in engineering. So as I said, number 7 is factored by synthetic division. I'm not presenting the factoring technique anymore. So this is these are the factors. So therefore, The denominator is 0 when x is 3 and when x is negative 2. So points of discontinuity, 3 and negative 2. Number 8, so I will not also show the factoring technique. The numerator need not be factored if it is factorable, because there's no harm for the numerator in finding the points of discontinuity. These are the factors. So therefore, in this case, x is 1/2 will make this 0, x is negative 1/2 will make this 0, and the remaining factor has no roots. If you evaluate the discriminant, 1 squared minus 4 times 1 times 1 is negative, so there's no real root for this factor here. So the points of discontinuity are x is plus minus 1/2. Then number 9, you should learn that the graph of cosine function is continuous everywhere from negative infinity to positive infinity. It will only oscillate between negative 1 and 1. Also, it will cross 0 also, but the low, the minimum value is negative 1, the positive value is 1. It oscillates between negative 1 and 1. Same is true for sine. Therefore, there's no point of discontinuities for cosine function as well as for sine function. So none for cosine. For sine function, it's also none. So you have to recall the graphs of cosine and sine from trigonometry. So that's it for this video, and I hope that you learned something.